Johnson. Welcome to the Home Time Project Center.
And I'm Peggy Knapp. In the video you're about to see, Dean and I will be showing you basic framing techniques as we build a room addition. From watching the program, you should be able to apply this information to other types of rough construction, like building a garage or a cabin. During the project, you'll be learning how to frame for doors and windows, how to install roof trusses, and later on we'll be showing you how to frame up interior walls.
Home Time is made possible by Chevrolet, who brings you full-size Chevy vans with full-size room and hauling power. Chevy Suburban, no car-type wagon can do as much. Full-size Blazer at home and backcountry or on a city street. Full-size Chevy pickups, full-size tough for full-size jobs. The heartbeat of America, today's Chevy trucks.
This video is just one in a library of instructional programs designed to assist the viewer in working on a wide range of home improvement projects. And before we begin our program, I want to explain how you can best make use of this educational system. First off, you should watch the tape all the way through to get an idea of the methods, the steps, and the terminology we use. To help familiarize yourself with the terms, we've included a glossary in the project guide. Then you should review the tape again, only this time, check with your project guide to determine the tools and materials appropriate to your project. Then take the project guide to your local building supply dealer or home center. The people there will be able to assist you, answer questions, and direct you to what you need. Now, before we start, we want to go through the basic steps that are involved in a typical room addition. First, planning and preparation.
This includes examining and making as-built plans of the existing house and designing and preparing construction drawings for the new addition. Submitting the construction drawings to the building department for appropriate permits. Giving a copy of the plans to the lumber yard to estimate materials. Gathering tools and equipment for the job.
Floor construction.
Installing the treated sill plate with sill sealer. Installing rim and floor joists. Installing the subfloor.
Wall construction.
Framing the walls and attaching them to the rim joists. Framing in for windows and doors. Aligning, plumbing, and bracing the walls. Applying the sheathing.
Roof construction.
Installing the roof trusses. Tying them to the existing roof. Bracing the trusses and applying the sheathing.
And that takes care of the framing for the room addition. We'll also be showing you interior framing, how to build partitions, false walls, and how to frame out around pipes and ductwork. Now, let's go to Peggy, who's going to talk about the materials we'll be using.
Dean and I will be framing out our room addition using construction lumber and connecting hardware. All construction lumber is cut from logs in standard sizes and graded according to its strength, moisture content, and appearance. The stamp on this 2x4 gives the name of the agency that certified the reliability of the wood following the criteria set down by the Department of Commerce. This number refers to the mill where the tree was cut into planks. Stud means that the wood is stud grade, that it's structurally sound to serve as a framing member for residential construction. This next term, S-dry, indicates the moisture content. And right beside that is the species, Doug fir. That refers to the tree, the Douglas fir. Now check with your lumber supplier to find out what grade of lumber is appropriate for your framing project. Now let's go to Dean, who'll tell us about dimensional lumber.
I'm going to use this stud as an example to explain the difference between nominal and actual dimensions of wood. The stud is the foot soldier, or the primary unit in residential construction. It's a vertical framing member that is actually no longer than 8 feet in length, and in most residential construction, it's either a 2x4 or a 2x6. More and more houses today are being framed with 2x6s to increase the insulation capacity of the walls. Now, I said this is a 2x6, but in actuality, it measures 1.5 inch by 5.5 inches. The reason it's called a 2x6 is because in its rough cut state, when the board is first cut from the log, it has a nominal dimension of 2 inches by 6 inches. Then when it's surfaced for smoothness and uniformity, it becomes 1.5 inches by 5.5 inches. So whether the board is called a 2x4, a 2x6, a 1x12, or whatever, you should remember that these are the nominal dimensions, when actually they measure somewhat less.
Successful wood framing requires careful planning, a knowledge of structure, and a skill with tools. Woodworking tools can be broken down into 5 basic categories: measuring tools, cutting tools, fastening tools, clamping tools, and surfacing tools. For framing, we'll be working predominantly with measuring tools, cutting tools, and fastening tools. The measuring tools will consist of tape measures, framing and combination squares, and a 4-foot carpenter's level. For cutting, we'll be using circular saws and reciprocal saws. And for fastening, we'll be working with a 20-ounce framing hammer. Now, the framing hammer is used predominantly in construction carpentry. It's heavier than a finish hammer to aid the carpenter in driving larger nails. Its straighter claw makes it easier to pull up boards and pry up nails from side to side. And the head is waffled to minimize the deflection of nails.
We'll be explaining the tools and their uses in more detail as we work with them during the program. Additional tools and equipment will include an electric drill with a spade bit, a chalk line, tool belts, safety glasses, extension ladders and step ladders, and our Chevy S10.
And just as important as the tools is the person who's operating them. Whether it's large or small construction, it requires care and patience, and your attitude plays an important part in the final outcome.
Which brings up the issue of safety. We'll be addressing safety equipment and procedures throughout the program, but I want to mention it up front. Be safety conscious. If you're in a hurry, or if you think you can get by without taking the proper safety precautions, then you're asking for trouble.
We recommend that you work at a comfortable pace, wear the proper clothing and protection, and follow the manufacturer's guidelines in using their tools, materials, and equipment. And another thing we recommend before beginning a framing project is to talk to your homeowner's insurance agent about builder's risk insurance to see if it can be included on your present policy.
The first stage in any framing project is planning and preparation. In other words, designing the project, checking building codes and permits that are applicable. Now, you may want to employ an architect to design the project. We took a sketch of our addition to architect Lloyd Jafford.
Lloyd, what is involved in building an addition like this, in designing an addition?
Well, I think the first thing is to come up with a good program.
And what's a program?
How you would use the space, your family, your lifestyle. Mm-hmm. In this particular program here, we're dealing with the existing kitchen, mm-hmm. which is right here, and our family room addition, which will be right out here. Mm-hmm. What we need to do is to figure how this space will relate to each other between the kitchen and the family room, how your family functions, really. Do you do formal entertaining? Will this be more informal? If you're working in the kitchen, do you want to be able to see your guests out here and talking to each other? And is it going to be used, is the family room going to be used, for instance, you have young kids, somewhere where they can play with their stuff, store it away when the company comes. And then I think, this also functions next to like the living room and the dining room, which are probably more formal spaces. So how do you deal with this? And do we relate the two together or not? I think one of the most important things in any program or setting up a design is how does it flow? What views are we trying to see in the end? Like for instance here, we're coming in the front of the house, and we have our entryway here. And right here we have our existing living room. Mm-hmm. Now we're going to be adding the family room area off of the back of the house, the existing house. And here's our existing kitchen. Mm-hmm. Well, one of the first problems I see when I come in the house is, how will I get to the family room? Mm-hmm. It's across another space now. And now this existing space, our kitchen here, which right now is very bright and light, probably will become darker, because now this space here is interior behind it. So I think the important thing now is, how do we function through here? Probably if this is the living room area, we don't want that, maybe we want to cut that off from the family room. Mm-hmm. So otherwise, if we don't and we come through it, we're going to really have circulation here. We'll come from the entryway and we'll have circulation here. Mm-hmm. You come by the cabinets and so in the kitchen, and you have circulation here. We go out to probably a deck or something out here, and you have circulation there. Now when we look at it, where do we put the furniture? Uh-huh. And I think the important thing in any planning or designing is to to lay out your space. This is south, so we probably want to look at getting the sunlight in here. We have a lake out here, I mean, a beautiful view. But if we're standing right here where we are now, and we add a room here, where we come in from here, we are not going to be able to probably see that lake the way we want. So maybe designing, we cut across here. Now if we're standing here looking out, all of a sudden we've opened another whole view of the space. And so I think anything that we can do to think about when we're standing in there, what time of the year it is. You know, the wintertime the sun is down lower, summertime it's higher. When we probably don't want the sun, it's going to get too hot. We're dealing with the kitchen, you know, so we probably want it cooler, yet we want it cheerful and bright because you're going to spend a lot of hours there. So I think we take any space, whether it's the family room, the kitchen, whatever, could be your master bedroom, but we see how do you live in there? How do you entertain? You know, is it more of your family or is it more formal? If it's your family, it's probably going to be, you know, a lot lighter. You probably don't care as much how things are set up and how formal they are. So what we have to do is look at all of those elements, and from that develop a plan that makes sense with their existing house. And when we add it, I think one of the key things always is to make it not look like an addition. Make it look like it was there originally. I mean, you see these additions with the big tacked on thing that looks strange. So I think what we want to do is create a space that looks like it probably could have been built there originally, yet get the flow, get the lifestyle of your family in it, and go from there and develop it.
All right, Lloyd, thanks. Well, now let's go back to our studio and get to work. Before we go to the site of our room addition, Dean and I want to give you a good idea of what framing involves. So here in the studio, we've built a foundation to illustrate typical floor and wall construction. Now, this particular foundation consists of a perimeter of concrete blocks. These hollow blocks are then filled with concrete, and half-inch anchor bolts are embedded every 4 feet on center to secure the wooden sill plate on which the walls will be built.
With the foundation in place, we can begin to frame out the floor. The first board we want to apply is the sill plate. But before we apply it, we need to set a layer of sill sealer on the foundation.
Sill sealer is made of fiberglass or a polyfilm material. Ours is polyfilm and comes in a roll 6 inches wide and 1/4 inch thick.
It serves as a gasket, stopping air infiltration and preventing moisture from penetrating the sill plate from the concrete block below. Depending on the area of the country you live in, a termite shield may also be required. The sill plate, or mud sill, is a straight board of preservative-treated wood that is bolted to the foundation block to provide a nailing surface for the floor joists. We're using 2x6 lumber, which we cut to fit the length of the foundation walls. To mark for the anchor bolts, we set the board up on the foundation and using a combination square, made a straight line on the wood and drilled for the bolts. For ease of fit, I made the holes 1/4 inch larger than the diameter of the bolts. Now for the hardware.
With the sill plate installed, we can begin to frame out our floor. The framing members that support the floor are called joists. Floor joists run parallel to each other and are spaced 16 inches apart from center to center. They come in different sizes and they vary depending on the span of the floor and the load that they'll carry. Now here again, you want to check with your building inspector on the codes that apply to your situation.
First off, we cut the perimeter or rim joists to the correct length. Set them on the sill plate and nail the corners together. Then we want to check for square, measuring diagonally from corner to corner. With that square, we can then toenail the rim joists to the sill plate, making sure that they're flush with the edges. Now we can mark off our 16-inch increments on the rim joists, making the first measurement 15 1/4 inches from the corner to compensate for the first joist. Then every 16 inches from there. Then comes the interior joist.
Before attaching the joist, you want to determine the high point or the crown. And you do that by sighting down the edges of the joist and looking to see which way it bows. And then you want to put that edge of the joist up, because over time the weight of the floor will straighten that bow out.
If the joist has any large knots in it, be sure to place those upward for greater strength. All right, liner. It's also a good idea to toenail the joist into the sill plate for internal support.
There are codes in certain areas that require bridging and solid blocking between the joists for extra stability. Now, this makes a stronger floor, and it also prevents the possibility of the joists ever twisting as they dry out. Now, solid blocking is when you use the same dimensional lumber as the joists, and it's typically used between two joists that are less than 16 inches apart on center. For instance, between the rim joist and the first joist, and it also provides extra structural rigidity. Solid blocking is also installed where support is needed for a non-bearing wall that's located above the joists. And to give support to a bearing wall, you'll need to double up the joists like this. Another method is cross-bridging with 1x3 material or manufactured metal braces. Be sure to check your local codes for the bridging required in your area. Now for the subfloor. Here we're using 1/2-inch CDX plywood. The CD refers to the grade of plywood, and the X means that the layers, or ply, are glued together with exterior glue. Now I've laid a bead of construction adhesive along the middle of the joists. This not only adds to the staying power, but it also minimizes squeaks. Now when installing the subfloor, you want to lay out the panels of plywood so they're perpendicular to the joists, but you want to leave a gap for expansion. And here, a 10-penny nail works great as a spacer.
With the subfloor down, we can now install the walls. Residential walls are constructed with vertical studs placed 16 inches apart from the center of one stud to the center of the next. The most common method used for framing is to lay out and assemble one full length of wall at a time on the floor or level ground, and then tilt the entire thing into place.
First, we want to measure and cut the top plate and the bottom plate, also known as the sole plate. Got it?
Yep.
Then, setting them together on edge, we measure and mark for the studs in the same way we did for the joists. First, we'll measure out 15 1/4 inches. Then, holding the tape on that mark, we continue marking every 16 inches. That way, our studs line up with the joists. Most steel-bladed tape measures come with arrows or highlighted indicators every 16 inches to speed up this task.
Then, with a combination square, I draw a line and mark an X to the right side of the line. This locates the stud on the right side of the line.
The longer the 2x4s you use for the top plate and the sole plate, the better. If the length of the wall is such that you need to butt two 2x4s together, they should join at a 16-inch mark where they can be nailed into a stud or into a joist. After the walls are in place, another top plate or cap plate will be attached to this top plate, overlapping at the joints.
Now to lay out the studs. For standard 8-foot ceilings, studs can be purchased pre-cut to 92 5/8 inches. This length is perfect for 8-foot ceilings because when added to the combined 4 1/2 inches of the top plates and sole plates, it comes to 97 1/8 inches. Now, subtract the 1/2 inch needed for the underlayment, and you have the 8 foot you need for the interior drywall, plus 5/8 inch extra for fitting the ceiling panels. Right there.
To secure the studs to the plates, we nail two 16-penny nails through the top and bottom plates and into the studs, like so. Again, in laying out your wall, you'll want to line up the studs with the floor joists. This helps both structurally and for purposes of running vents. And this forms the basis for the most commonly used method of residential framing. There's one more important factor we need to address: the corners.
Since the second wall we're about to build will butt up against this wall, it'll require special corner posts built in such a way that the other walls can be nailed into them, and so that the interior drywall and paneling has an inside nailing surface to anchor to. To construct the corner posts, you want to sandwich 3 pieces of 2x4 between the studs. There you go. For certain structural situations, this must be a solid post. Before we raise this wall, we want to tack a couple of pieces of wood to the rim joists. These are called keepers, and they'll keep the wall from slipping as we tilt it up. We'll nail the sole plate to the rim joist, making sure the outside edge is flush. We then plumb and temporarily brace the wall. Let's say we want to frame out a door in our next wall. First, we want to know where the center of the door opening is located. Let's say it's 4 feet from the corner. So we want to measure in 4 feet to the center of the door, draw a line, and mark a C on the bottom plate, like I've done here. Now, given the dimensions of our interior door, which is 30 inches wide by 82 inches high, we want to calculate the rough opening. By rough opening, we mean the framing dimensions of the door, which is 30 inches wide, plus the thickness of the door jamb, which is 3/4 of an inch on each side, plus an extra 1/4 inch on each side for shimming the door plumb, which in this case comes to a total of 32 inches, or 16 inches from each side of center. We lay out the remaining studs in the wall, again starting from one end and measuring out 16 inches from center on each stud.
Now that the stud wall is assembled, we can measure for the height of the rough opening. Measure from the bottom of the sole plate up 82 inches on both sides of the doorway. Thanks. And that will determine the location of the header. Now, the header is a fabricated horizontal framing member that supports the weight of the ceiling, the wall, and the floor above the door opening. This header can be made using 2x4s, 2x6s, 2x8s, 2x10s, or 2x12s. The size of the header depends on the span of the opening and whether or not the wall is a load-bearing wall or a non-load-bearing wall. Load-bearing walls do just that. They bear the weight of the house. You'll usually find them running perpendicular to the floor joists and ceiling joists or rafters. Non-bearing walls don't support but serve as partitions between rooms. For our demonstration wall, we're going to use 2x6 lumber for the header. Now, in terms of the length, we'll include 3 inches more than the width of the rough opening to allow for the jack studs, which will support the header.
For our header, we've spiked together 2 2x6 boards with a 1/2 inch plywood insert. The extra 1/2 inch will bring the header flush with the sides of the framing members for applying sheathing materials.
The header is located between these 2 studs. They're called king studs. The king studs run the full length between the plates and form the basis of the rough door opening. Now, the header is supported by shortened studs called jack studs that are nailed to the inside of the king studs, which will bring us to 32 inches, or the width of our rough opening. The header is then nailed to one king stud, and then we nail it to the other king stud, which will bring us to 82 inches, or the height of our rough opening. Then we need to fit shorter 2x4s called cripple studs in the opening between the header and the top plate where studs would normally be nailed 16 inches on center. Once the wall is raised, plumbed, and secured to the subfloor, then the portion of the sole plate within the door opening can be cut out. By waiting until the wall is secured, you keep the door opening aligned and square until it's time to install the door. The exact dimensions of the rough opening and all the framing members should conform to the size of the door and the manufacturer's recommendations. Let's go. Okay, it's plumb.
All right, with the walls plumb, we can now nail them together. As we mentioned before, by building out this corner, we now have a nailing surface for our drywall. Framing out a wall with a window is much the same process as that of a door, with the addition of a windowsill. Here again, the rough opening is determined by the width and height of a window. Whatever that is, you want to include an additional ½ inch on all sides for ease of installation and shimming for square. Here again, it's best to check with the manufacturer's recommended rough opening.
After marking our top and bottom plates, we follow our plan and indicate where the center of the window will be. Next, we lay out the pre-cut studs, again starting from one end, measuring out 16 inches on center for each stud. Then we add the jack studs for our sill, the sill itself, our header jack studs, and the header. The header is the same that we used for the door, a single piece of ½ inch plywood cut to fit and sandwiched between two 2x6s. For the sill, we're using a straight 2x4. If the window span was greater than 4 feet, we would double the sill. Then we supply extra support with the cripple studs, under the sill and between the header and the top plate. Now you have the fundamentals of residential wall construction.
Let's go to the site of our room addition where we'll be raising those walls. As you can see, we're doing some things a little differently here. We're erecting the walls with the exterior sheathing already installed. And since the first floor of our addition is a poured concrete slab, a floor joist system won't be necessary. The sole plate will be attached using anchor bolts, as we did in the studio. We also have the element of the existing structure, to which our room addition must relate. That means we have to remove the siding and tie the new construction into the existing framing. And we have to make sure that the elevations of our new walls and floors will line up with those of the old. To do this, once all the framing members are exposed, I measure from the top of the new sole plate to the bottom of the existing top plate. This gives me the length of our new studs.
It's a lot easier and faster to assemble the walls with the exterior sheathing already attached. You can do it all on the ground, and it saves the time it takes climbing up and down the ladders. Of course, pre-sheathing makes the walls a lot heavier, so if you plan on doing it this way, be sure to have plenty of help. We attach the ½ inch plywood sheathing using coated 8-penny nails, set every 6 inches along the perimeter and about every 8 inches along the interior studs. Now, this corner section will be sheathed after we have the wall in place to accommodate the overlap of the adjacent wall.
We erected the side walls first by fastening the sill plates to the anchor bolts. Then we brace the sides with 2x4s fastened to stakes embedded in the ground. We'll keep these braces attached until the joists and subfloor for the second story are installed. Now we're ready to tilt up the end wall.
Instead of 2x4s, we're using 2x6s as framing members for the addition. This provides additional insulating capacity for the same amount of labor and just a little more expense. We want to lift the wall evenly to avoid any buckling. First, we raise the wall to a standing position, then lift it and set it over the pre-drilled holes for the anchor bolts. If measured and drilled properly, the sill plate then will slide down into position. Having a pry bar handy in case the sill plate needs a little coaxing is also a good idea. Then, with one person securing the sill plate by attaching the washers and nuts to the anchor bolts, another can prepare to align and plumb the walls. Okay, pull it in a little bit more. Oh, that's perfect. Good. Looks good. Okay, looks good.
We didn't want to drive the nails all the way until all the walls were plumb. The last thing in framing out a stud wall are the cap plates. Here on the end wall, the cap plate overlaps the side wall, thereby strengthening the corner connection.
It's good. The next step in our construction is the installation of the rim joists, the joist hangers, and the floor joists for the second story. Now, just as we did in our studio, the rim joists are constructed of 2x10s set on edge around the perimeter of the structure and set flush with the cap plate to allow for installation of the plywood sheathing. Okay, let's go ahead and nail it. To tie in the floor joist to the rear rim joist that runs along the wall of our existing structure, we're using joist hangers. These are manufactured metal supports that are nailed into the rim joist at 16 inches on center. The floor joists are then set into the slot and anchored with special joist hanger nails. The nails can be driven into the side of the joist without penetrating the other side. When it comes to framing, a circular saw is one of those can't-do without tools. It's a very powerful, all-purpose cutting tool that with the right blade can be used to make a variety of saw cuts. Now, so far on our project, we've been working with a cross-cut blade for trimming boards to length. But no matter what the saw cut, when using the circular saw, certain safety precautions need to be followed. So be sure to read the manufacturer's safety guidelines. Now for the subfloor. We want to lay out the sheets of plywood lengthwise, perpendicular to the joists for strength. Now, before setting out the sheets, we ran a bead of construction adhesive along the top of each joist. This not only strengthens the bond between the subfloor and the joist, it also minimizes squeaks. Ready? Okay.
We then begin nailing the subfloor down. First, we want to measure for the location of our joists along the outside edge every 16 inches. Then we mark along the inside edge. We then nail the outside using 8-penny nails at about 6 inches on center. And before nailing the inside, we align our joists with our marks. By following this procedure with each sheet, we can correct any bowing of the joists as we go along.
To begin the second row, we want to make sure to stagger the seams from one row to the next, so we're positioning the sheet here. After the full sheets are in place, we can come back, trim, and position the smaller pieces where needed. Remember, when butting two panels together, to leave a 1/8 inch gap for expansion.
As you can see, we've added 2x10 blocking in between our end joists and our first joists for additional strength. We've done the same thing on the other side of the addition. We've also nailed the top portion of our bridging. Once all the plywood subfloor is down and nailed, we'll nail the rest from below. We also took the time now to install a 2x4 nailer for our drywall ceiling to be installed later.
Okay. With the subfloor down, we've begun constructing the walls for the second story. In preparation for raising and locating the walls, we've removed the sheathing, as well as the soffit, the fascia, and the trim, in order to expose our existing framing. To determine the length of the studs, we use the same method that we did downstairs, measuring from the top of the new sole plate to the bottom of the existing top plate. Now, we also want to check and make sure that the existing wall is plumb, which it is. But if it hadn't been, we would have adjusted the new top and sole plates accordingly. As you can see, our existing structure was built using insulating sheathing instead of the plywood that's called for in our plan. Because insulating sheathing doesn't provide sufficient structural rigidity, these metal braces were installed, placed diagonally across the stud wall.
To take advantage of the surrounding lake views, we've opted for corner windows on both stories of the addition. We've substituted a 6x6 post for the traditional corner frame that you saw us install in the studio. This will give us a relatively uninterrupted view of the lake going from one window to the other. The one difference in framing this window can be seen here. The header rests on top of a 6x6 post rather than being nailed into the side of the king stud. Other than that, the framing's fairly traditional. The top plate rests on top of the header and the cap plate on top of that. Once all the walls are raised in plumb, the cap plate will be added to this wall, thereby strengthening this corner position. Now it's time to sheathe and raise this wall using our keepers. Once we've removed all the shingles, we want to cut away the plywood sheathing flush with the outside edge of the existing cap plate. With all the plywood sheathing removed, we want to cut off these rafter tails using a reciprocating saw, making sure that we cut them flush with the outside edge of the existing cap plate. You can go through a lot of lumber putting up a frame. It's real helpful to have a vehicle that can carry most everything you need. Our Chevy 4x4 S10 pickup is perfect for the job. The bed can take a blow from a 2x6 or toolbox without putting a wrinkle on the outside, thanks to the double wall construction in the box sidewalls. The front fenders, hood, and tailgate are built that way too. If you need a trailer, a properly equipped S10 with the optional fuel-injected V6 can tow up to 4,000 pounds of trailer and cargo.
And when it's time to get away from the job, this S10 has four-wheel drive. Take you anywhere you want to go. InstaTrack, the patented 4x4 system, lets you shift from two-wheel drive to four-wheel drive high and back again at any speed. It's comfortable inside, too, with full foam cushions and seat backs. And it has more legroom than a full-size pickup.
The exterior styling is crisp and clean, with a 4-layer paint finish, plus an extra 5th layer of chip-resistant protection on the lower body side panels. All in all, the Chevy S10 looks good and works hard. It's an ideal compact truck for us, and maybe for you too.
In the planning stages for your addition, you'll discover that there are many different types of roof styles and slopes. For our room addition, we decided to follow the architectural design of the existing structure and build a gable roof with the same pitch. To do this, we'll use prefabricated roof trusses designed to give us an 8/12 pitch and a 3/12 interior vault. In other words, our finished roof will rise 8 inches for every 12 inches it runs, and the interior ceiling will rise 3 inches for every 12 it runs, giving us the cathedral effect that we're after.
Trusses have all the elements of a conventional rafter framework, except they're easier and quicker to put up. And because of the speed in which they can be erected, they're used in most new housing. And speed is important when you need to get that new structure enclosed. The first step is getting them up on the roof.
Again, you'll need some friends to help, so if you've got any favors out, it's time to call them in. Now we're going to get all the trusses on the roof first, bringing them up in the reverse order of the sequence in which they'll be installed. So the first to go up will be the gable end truss. This will butt up against the last scissor truss and support the additional framing members we'll require to secure our new roof to the old.
We've driven a stake into the ground at the base of each ladder and tied off the bottom rungs to the stakes. This will prevent the ladders from kicking out as we walk the trusses to the top. The truss tails are then rested on the cap plate as the truss is slid over to the existing roof.
Once the trusses are all up, we measure for the position of the rafter ties, which are prefabricated metal fasteners. The first truss to be installed is the drop end truss, toe-nailed and braced. Next comes the succeeding scissor trusses, placed in the rafter ties and raised with the help of a 2x4. The last truss is called a gable end truss, which is secured into the existing rim joist. Now we plumb and brace, starting with the drop end truss. Then we plumb the succeeding trusses off it by marking an 18-foot 2x4 every 24 inches on center, aligning each scissors truss to the marks, and then securing with a 16-penny nail.
Okay, up just a little bit. All right, fine. That's good right there. The final brace is for the gable end truss that will connect the new roof to the old. With that truss plumbed and the brace secured, we can begin to measure for the ridge board. Using a chalk line resting on the peak of the trusses, we can determine where the ridge board will rest on the roof. Now we can measure it for length, scribe the existing roof's pitch onto the board, cut it to length, and secure it in place.
Then determine the angle cut so that it meets the pitch of the existing roof. Scribe, cut, and secure it in place.
We added a 2x4 nailer on the back side of the truss before securing the ridge board into position.
Then we lay out for the first nailer for the valley rafters. Measure, scribe for the compound miter cut and make the cut.
A compound miter cut is so called because you're cutting for two angles simultaneously. Here Peggy adjusts the blade to the scribe marks on the 2-inch side of the board, then cuts along the second mark on the 6-inch side. If measured and cut accurately, the compound miter will then match both angles, fitting snugly into position.
Bring it into position, secure it to the roof, and repeat the process for the other side.
When securing the nailer to the roof, you want to make sure that the nails land into the existing roof's framing members. Our existing trusses are 24 inches on center. Then we can repeat the process for the other side.
Now we can scribe, cut, and fit the rafters, starting with the far end and working towards the new addition.
Used in combination with measuring, scribing in place is a quick way to mark for difficult compound miter cuts. As an example, where rafters meet the valley nailer. Using the length measurement for the top edge of the rafter as our guide, we can cut the appropriate angle for where the rafter will meet the ridge board and scribe the bottom for the first miter cut. With that cut made, we can reposition the rafter and scribe for the second miter cut required. Now with the saw blade adjusted for the compound miter's position, we can measure for, cut, and secure the remaining rafters. Here I'll add a temporary brace across the top of the trusses in preparation for the sheathing.
The next step is to install the lookouts, which are 2x4 framing members that are nailed into the first scissors truss and toe-nailed into the drop-end truss.
With the lookouts in place, Peggy can now trim the rafter tails, matching their length to the existing structures. She does this by transferring the measurement to a level, then marking for the tail's length. Marking the first, then the last, and using a chalk line guarantees an even appearance for the overhang.
After the lookouts are installed, we trim the rafter tails to match the existing soffit.
We added a final framing member on the end of the lookouts to complete their installation.
Now we can bring up the sheathing for the roof, again staggering the seams as we lay each piece down.
Where the new sheathing meets the old, we measure for the top and bottom of each panel. Calculate the angle. Make the cut. Then position the spacers and fit and nail the panel.
Spacers are prefabricated metal clips and are used to eliminate the sagging of the plywood panels between the 24-inch on center trusses.
The final step of the roughing in process is to trim the sheathing and apply the roof felt as a protective covering.
What do you think?
Looks great.
With the room addition completely sheathed, we've now finished that portion of the framing.
And now we want to show you what's involved in interior framing.
Now here in the basement, we want to go over what's involved in framing up for interior walls.
The construction of the interior walls is much the same as the exterior walls. The only real difference is connecting the new walls to the existing floor and ceiling. Now there are 3 typical situations that you may run into, and we're going to show you each of them.
The first wall we'll install is where the new wall runs parallel to the joists.
Your first step is to establish the location of all your new walls. You may find that in many older homes the walls won't be square or plumb, so it's essential that you make accurate measurements. We laid a straight 2x4 down on the floor to check for any irregularities, places where the sole plate might require shims.
With our location mapped out, we can now begin assembling our wall units. On interior non-load-bearing walls, we only need 1 top plate. To determine the length of your studs, there are 2 common methods. You can measure the distance from the floor to the bottom of the joist for each stud across the span at 16-inch on center, remembering to subtract from your total the 3 inches for the top and sole plate. This way, each stud must be measured and cut individually. The method we'll use is to measure the same way, but we take the shortest measurement, cut all the studs to that length, and assemble the wall. First, we add blocking in between the joists using scrap 2x4s 3/4 of an inch from the bottom of the joist. Then we place a 1x6 on the bottom of the blocking, flush with the floor joists. To this we nail our top plate.
Then we raise the wall, locating it on the chalk line, checking the wall for plumb. As you can see, the 1x6 gives us the nailing surface we need for our drywall ceiling.
The next step is to shim the wall by placing shims in between the top plate and our 1x6 nailer. Now we're using pre-cut shims you can get at your local lumber yard. To do this, we'll take a couple of shims, place them on either side above the top plate, like so. Then using a hammer, we'll gently tap the shims on either side until the wall's firmly in position. Then we plumb one last time, nail through the top plate, up through the shims, making sure that we land the nail into one of our 2x4 spacers. Once this is nailed into position, we take a utility knife, score either side of the shim, and break off the excess shim. Now the question arises, what if you're installing a new wall in an area where the joists aren't exposed? Let's go to Peggy, who will show you how to locate those joists before installing the wall without removing any ceiling coverings.
The easiest way to locate a joist is by using your ears. By tapping on the ceiling, you'll hear where the sound changes. There, can you hear it? It sounds higher there. And not quite so hollow. You can also feel a little bit of resistance. Now to check and make sure that that's where the joist is, I'll just tap in a little finishing nail. No, not quite. There it is. And don't worry about the little holes in the ceiling. A little bit of plaster will fix those right up. All right, I know there's a joist right here. Now I have to determine whether it runs this way or this way. And again, tapping will tell you that. And I would say that the joists run this way. Now to locate the other ones, all you have to do is measure over 16 inches, and there should be another one.
For securing the treated sole plate to the concrete floor, we've rented a powder-actuated nail gun. It's called powder-actuated because it uses gunpowder. The nail is driven into the concrete by a .27 caliber shell. You want the nails to penetrate the concrete at least an inch. So for our purposes, we're going to use a 2 5/8 inch nail. As you can see, I'm nailing every 16 inches between the studs. Great care must be taken when using a powder-actuated nail gun. Protective glasses and gloves must always be worn by the operator and anyone else in the near vicinity. The gun should never be pointed anywhere but at the material and should never be left loaded when unattended.
The same method of wall construction that we just showed you also applies to a situation where the new wall runs perpendicular to the joists.
Because we're nailing this wall to our first one, we've added some additional blocking in between the studs as a nailing surface. Okay, ready? Drag it over. Further. Right there.
If you find yourself in a situation like this where you just don't have enough headroom to build the whole wall and then tilt it up into position, you may need to nail the sole and the top plates into their proper location first, and then toenail all the studs in.
Or you can assemble the wall, leaving the sole plate unattached. Position and fasten the sole plate in its proper location, then raise your framed wall, aligning and toenailing your studs to the sole plate.
Because we have enough room here, we can just utilize the space between the joists, and we'll raise the wall up and locate it in its position. Ready? Okay, bring it up. Okay. Over, over. Keep coming. Good. Okay.
Pretty close.
Then we shim.
Just hammer it in there now.
Plumb. Nail and secure it to our first wall.
We've built a furred-out wall on our concrete block foundation using a treated 2x4 turned on edge as our sole plate, 2x2s as studs, and a 2x4 as our top plate. Again, extreme care must be used in operating the nailer. We've placed our 2x2 studs 24 inches on center to accommodate pre-cut styrofoam insulation that comes 24 inches wide by 8 feet high by 1 inch thick. Once we've installed all the styrofoam insulation, we'll cover the entire wall using a plastic vapor barrier before we add our wall covering. Help you out here. Now, let's look at the framing of this doorway. First, we want to locate it on the floor with our framing square in its proper position. We want to come off this sole plate since we know that we squared it when we installed it. Our first step then, prior to laying out the wall, will be to install the necessary blocking between our joists so that we have a nailing surface for our top plate. Then we'll want to install additional 2x4 studs here in this bearing wall so that we have a nailing surface to accept the end studs of the doorway wall. We'll also install an additional stud here so we'll have a nailing surface for our drywall. The bearing wall is identified by the overlapping joist ends above it. We also can see that blocking had been put in the wall when first constructed to give it the extra support required for a bearing wall.
While Dean installs the joist blocking and the additional studs, I'll begin to lay out the framing. First, we mark our top and sole plates. Using the tape measure and combination square, we mark our center, then we measure for our rough opening. Next, we'll locate the jack studs then the king studs, then the end studs. We'll cut and position our end and king studs, then measure up for the location of the header. We'll build the header with 2x6 lumber and 1/2 inch plywood. Then measure, cut, and fit our jack studs for below the header and cripple studs for between the header and top plate. Then we assemble and raise the wall into its proper location. Shim, check for plumb, then secure our top plate. Now to secure the sole plate. Since we'll be removing the portion of the sole plate within the rough opening when the door is installed, we want to fasten it to the floor here, on either side of the rough opening. But because there isn't enough room in here to use the powder-actuated nailer, we've applied construction adhesive below the sole plate before we raised it up. Now we'll provide additional support by toe-nailing the sole plate here into the sole plates of both supporting walls. In combination with the construction adhesive, the sole plate will then be permanently secured to the floor in its proper location. Then, we complete the nailing of our end studs into our supports. Keep in mind that shims may be required here if the existing wall is out of plumb with our new construction. The last framing project we want to show you is for enclosing basement pipes and ductwork. And to do that, we need to construct a 3-sided box or a soffit out of 2x2 lumber. First, we mark the location of the soffit on our joists with the chalk line. Then we assembled the sides, cutting a top and bottom plate and connecting them with cross pieces.
Okay, got it?
Then we anchored them to the ceiling joists. Now we want to install the bottom section to the sides. The 2x2 framing members might split if we fastened them together with hammer and nails. So instead, we're using drywall screws and a cordless drill with Phillips head bit. Notice that the cross members have been located 16 inches on center to accommodate the installation of the drywall.
This framework can also be used to construct soffits above kitchen cabinets and bookcases.
We covered a lot of framing applications, and these were just the basics. With the knowledge and experience that comes from framing out walls, you can move on to more sophisticated framing, like building stairways and dormers.
We hope this video helps make your framing projects more manageable. There are variables with every remodeling project, particular problems that are special to your house that we were unable to cover in our video presentation.
For additional information on the subject of framing, check the bibliography in the companion guidebook. And if you're planning to do more home projects, be sure and check out our other titles. I'm Peggy Knapp.
And I'm Dean Johnson. So long.
Home Time is made possible by Chevrolet, who brings you Chevy Suburban, America's superwagon, Chevy Astro, the van that can, S10 Blazer, America's most popular sport utility vehicle, full-size Chevy pickups, full-size tough for full-size jobs, the heartbeat of America, today's Chevy trucks.